Under your notes, please title this scientific notation. Why is this confused? Under scientific notation, the little subheading, we've already done scientific notation, operations with small numbers. Right. And the basic gist of this, you guys kind of proved it with your whole spiel here. Anytime you work with really, really small numbers, or big, small decimal numbers, things get a little confusing. In our modern world, with all the stuff, I mean, microcomputers and all the stuff we have now, you actually do have to work with small numbers because, 500 years ago, we didn't get much smaller than, fractions of an inch because we didn't have things to measure that. But now we can measure things to whatever. So you have to be able to, at some point, be able to do this. So the deal was with this. The first thing you would do on this is if I made this scientific notation, I would move that decimal right to here. And it would be 2.4, right? Yeah. 10 to the, how many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8. But it's not 10 to the positive 8, it is 10 to the negative 8 because it's a decimal number. And to that, I am multiplying 6.0, or just 6, you don't have to put the 0.0 there, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, negative 9th power. And the reason why you do it in scientific notation because it is just a lot easier. You don't get confused by all of these zeros you got standing there. You can just do it the way we talked about. How do we multiply in scientific notation? It's a 3-step process. You multiply the left sides, which I'm guessing is where you got the 144. But there's also a decimal where in 144? Has to go right here, right? Because there's one decimal place there. I didn't multiply by 60. So I get 14.4 times 10. What do I get for my exponent? Well, when you multiply, you add these together, but you have to remember you are adding 8 negatives with 9 negatives, which gives you a total of 17 negatives. So that's kind of my answer except for one small fact, and that fact is, I can't have a 14 in scientific notation. So I have to move this decimal and make it 1.44, and this is where people go wrong, so you have to focus on this. You are either going to add 1 or subtract 1 from that. That's either going to be negative 16 or negative 18. What tells you that? Well, if you make this number smaller, which I did, you balance that out by making that number 1 bigger. And what is 1 bigger than negative 17? Negative 16. So whoever said the one that had 15 zeros would have gotten that right, because one of the places gets stuck there, and then you have to add 15 zeros. So how many people got the 15 zeros? All right. And again, the deal with this is not hard multiplication. I mean, most everybody got the 144. It's just when you start throwing all those zeros in there and you're trying to keep it all straight. And that's the same thing with division. What if I gave you this same exact problem but made it division? That would probably be even more complicated. Because then you got to move all your, well, actually it wouldn't be that hard. Well, yes, it would. Actually, it wouldn't be that hard because you'd have to move this decimal over that many places and then you'd have to move that one. And it actually would not be that bad. But let's do it in scientific notation as a division problem. We'd end up, let's call it this divided by that. So 2.4 times 10 to the negative 8th divided by 6 times 10 to the negative 9th power. Fortunately for y'all, I picked 2 numbers that are pretty easy to divide. What is, you divide the left side, what's 2.4 divided by 6? 0.4, right? Stop me if I'm wrong. and then I put times 10. Here's where also you have to be very careful. What's different about division and multiplication is I need to subtract the bottom from that. But watch what happens here. I subtract a negative 9. When you subtract a negative, really that becomes, Sam? Right, you're actually taking negative 8 plus 9, because two negatives next to each other make a positive. So negative 8 plus 9 is a 1. But again, I can't keep this here because this is not scientific notation. I need to move my decimal one place to the right, making this 1 bigger, so I have to make that 1 smaller, and I get 10 to the 0. And again, ladies and gentlemen, let me reiterate this. 10 to the 0 power is not the same thing as 10 to the first power. If it's 10 to the 0 power in scientific notation, that is how you have to keep it. Technically, it is just 4, correct? Because 10 to the 0 power is 1. 4 times 1 is 4. But this is how you have to keep it. You can't just remove the 0 part there. So hopefully you can see how scientific notation makes things, should make things a little easier for you. Let me see what else they give you. Maybe I'll give you one to try. Let's give you one more to do. How about this? Let's see if we're ready for some mathematicals here. 8.1 times 10 to the negative 4th power divided by, I don't know, 3 times 10 to the negative 7th. Let's see what you get for that problem. Answers are done. But who wants to take a shot at it? Kevin Wills.
2.7 times 10 to the 3rd.
10 to the 3rd. Are we good with that? 3 goes into 8.1. I do agree it's 2.7. You write down times 10. You subtract a negative 7, and that becomes positive 7. Now, one last thing here. Look in your books, please, at page 391. Let's see if this makes sense to you. Look at the very top of 391 where it says letter I up there. It says a dollar bill weighs about, what's that, 1/1000th of a kilogram. What's the weight of $1 million bills? Now, first of all, ladies and gentlemen, sometimes people get confused as to whether you multiply or divide. And let me tell you this, if that's you, which sometimes it's me, I do this regularly, okay? If you don't know what to do, put other easier numbers in for it and see if you multiply or divide. For example, if a dollar bill weighed 2 pounds and you had 20 of them, how would you figure out what would be the answer to that? 2 pounds each, 20 of them, you'd multiply. So that's what this is. It's a multiplication. They say to write it in scientific notation and do it, so you got 0.001 and you're multiplying that by 1 million. I believe it's that. So it's a pretty simple thing. In scientific notation, this is 1 times 10 to the negative 3rd power, and I am multiplying that by 1 times 10 to the 6th power. Oops. Look how easy that is. You get 1 times 10 to the, what's that? 3rd, right? You add those together, you get 3. So there would be your answer. It's same as what? 1 to the 3rd power is what? in real number times. Kevin will, 1130. Very good. We're gonna stop there so you can have your cake and eat it too.